or Museum of the Paranormal. Others may know me for my work on in paranormal research. I am the founder of the National Registry of Paranormal Investigators. We have over 2,400 investigators worldwide registered on this website. Anybody who has a group can go under and check see if you're registered or not. Next. I am also the founder/co-founder of the New England Center for the Advancement of Paranormal Science. And a lot of the things we do at the Paranormal Center, we do a lot of work in statistical research and a lot of the real hardcore scientific data gathering. For example, we have one particular study that we're doing dealing with geological correlations and geographical correlations, and we found a lot of statistics that were not previously known. So we're actually making some breakthroughs here and pulling a lot of data together and putting together big databases and a map of paranormal locations throughout the United States. We have over 30 affiliates nationwide that are helping us put this together. It's pretty interesting. Now, there's a lot of talk in the paranormal community about science and what is science and what isn't science. A lot of people think that paranormal research isn't science. They think it's bunk, or they think it's pseudoscience, or a different kind of thing. But what I want to know is there anybody here that can tell me what the definition is of science? Anybody know the actual definition of the word science?
Something that repeat. Something that's repeated.
That's
a result that's repeated.
A result that's repeated. That is an aspect of scientific research. That's one thing that helps qualify it. The actual definition is a knowledge or a system of knowledge covering the general truths with the operation of general laws concerned with the physical world and its phenomena. Now, physical doesn't necessarily that it's touchable. Physical means that it deals with the aspects of physics. We're dealing with the physical world, something that deals with physics. And when we see something, when we see an apparition, when we see shadows and such, we're actually looking at the change in photons or release of photons, either emitted or reflected. That's measurable. When we hear footsteps or sounds or voices, that's something that's measurable. That's moving of air molecules. When we see a door slam or something move or something get moved on its own, that's manipulation of matter. That is measurable. We are dealing with a physical science. Okay? So, the question is paranormal research science or pseudoscience? You know, that's been a big debate that's been going on. Most recently, I've heard a lot of it about that. Actually, the fact is that you cannot tie this classification of scientific or pseudoscience to the field itself. It can only be applied to the research methods. I'll give you an example. If I were to say, if we were talking about where babies come from, okay? And don't worry, I'm not going anywhere. If we were to talk about where babies come from, and I were to say, and I would establish the position of babies come from the supermarket and stores, okay? And I was doing study on that, and I was looking around trying to find proof of that. But you came along and you told me, no, it's a biological process and it has to do with reproductive organs and all that sort of stuff. We are both studying where babies came from. That particular study is not pseudoscientific. The methods that we're using, my method is pseudoscientific because I do not allow for any other information to come in and change what I'm thinking or have it to grow or to advance. His method would be scientific. So it can be applied to the research methods. You can have a pseudoscientific group and have pseudoscientific methods, but you're not dealing with science, okay? And conversely, you can have somebody that's dealing with scientific methods, things that are where you're gathering data. You allow for other people's input. You allow for growing. If you have a group and you want to know if you fall into the pseudoscientific method, you can go to the kneecaps.org and take a look in the lab section. There's an actual checklist that helps classify and determine whether you have pseudoscientific or scientific methods. And I'll kind of clarify it a little bit. You get to get a picture of what pseudoscientific actually is. But whether you are psychic, pseudoscientific, a detective, whatever you might be, you are looking for energy. We are all looking for energy because everything in this universe, from this room to the ends of the universe, is energy. When you're hungry and you eat, you're looking for energy. When you're tired and you sleep, you are looking for energy. When you're at a house until 4 a.m. with bloodshot eyes, a caffeine hangover, and wondering if that growling you just heard was your flatulent teammate, you're looking for energy. Okay? And that's what we want to find out. The problem is, you know, we have a lot of energy in the universe. In fact, there's been 10 specific types of energy found since the beginning of time. Most recently, in the 1930s, we discovered nuclear energy, atomic energy. That before was an unknown energy. The energy that we're dealing with now in paranormal research is, in fact, unknown. We are looking at impacts from this unknown energy on our physical environment. When we introduce this paranormal type energy into our room, it's impacting the other energy sources that are in the room and making them change and do things that they're not typically supposed to do. So that's what we measure. We measure the physical aspects of that. That's what makes this a science to every degree, provided you go along with the scientific methods. Okay, so we're dealing with an unknown energy. Here's a perfect example, the sun. For a lot of years, people thought that the light, the heat from the sun, came from just a bunch of burning gases. We know now that this is millions and trillions of atomic explosions going off at one time. The sun is atomic, it's nuclear. But we didn't know what nuclear really was until the 30s, when we discovered that we could split atoms and we could have all this kind of energy come from that atomic energy. It was an unknown energy, and this is the key of what we're looking at when we're talking about energy interfering with other energies, because the energy from the sun really supplies almost every bit of energy that we get to use here, that we can do work with, as they call it physics. Light our lights, to heat our homes, to do all of this, it comes from the sun, one way or another. If we take a close look at the sun, here's a perfect example. The sun is a very magnetic thing, very, very powerful, very, very magnetic. In fact, that's what would cause it to collapse when it finally runs out of energy. But if we look closely at the surface of the sun, we see that all of the solar flares, which, by the way, each one of these is about 2 or 3 times the size of the Earth. They're huge. But because of the sun's magnetic energy, it affects the atmosphere of the sun and the gases and pulls them into the path of magnetic energy. This is the shape that magnetic energy looks like. If you could see it with your eyes, if you could see magnetic energy with your eyes, this is what it would look like. It would be angles and circles and all these twists and turns. It's pretty interesting. And this is a diagram that they have done in a science lab, mapping out the magnetic lines of the sun. So if you could see magnets and magnetic energy turned out to be green, this is what you would see. It looked like a big ball of hair. It would be all around us. It's not just the sun. Okay? Now, the aurora borealis is a perfect example of this. The energy from the sun comes down and hits with the ions in our atmosphere, and when they start to stabilize, they release photons in different color levels. Perfect example of one energy affecting another. Okay? That's what we're dealing with in paranormal research. One energy affecting another. We got to find the tracks of this. And why do we do this? And why do you think we do this? You know, if I were to go out and I wanted to learn about animals, I would want to track the animal more so than just get a picture of it. Because by tracking the animal, I can tell where it's been, where it's lived, where it hangs out, where it eats. With just a photo, I cannot do that. And you can approach that same method in your paranormal research. You're looking at this. It's better to have all of the scientific data that tracks the trail of whatever it is you're looking for, rather than a photo. Everybody wants to get that photo to say, look at that. Well, it's pretty cool, but you really don't know what you have a picture of if you don't have all the other data to go along with it. So we look at the energy, how it impacts our environment. Now, the problem that we're dealing with here is, like I mentioned before, the energy that we're looking for is, in fact, invisible. We can't see it. We can't see it at all. And that makes it very difficult to find, doesn't it? I mean, you have to figure out what it is that's coming here. We have no methods of detecting energy. If you think you have a machine that detects paranormal energy, you are sorely mistaken. There is nothing that detects paranormal energy. Nothing. What you have detects what it was made to do. Your EMF meter detects electromagnetic fields. Your electric field meter detects electric fields. Your thermometer detects temperatures. Those are what those things are designed to do. They do not detect ghosts. Nobody with a paranormal research team goes out and detects ghosts. You try to find evidence that supports the idea that something paranormal was in the room with you. Something that was there that wasn't supposed to be there. And that's where we got to find the pieces, put them together, and see what we can get in a big picture or puzzle. So if you have a meter, and you're going out with the meter into the room, the problem is your meter only sees about a foot around it, in a circumference of about a foot. Your EMF meter can only detect about a foot away. So the problem is you go in here, you actually have a meter in this big dark room. Now try to picture, if you can, walking through a dark room, completely black. You can only see a foot in front of you, and you have to find something in that room. You don't know where it is. It can move, it may change, it may dissipate, it may leave, and you've got to find it with this little ball. You can only see something about a foot in front of you. The chances of you getting an actual hit or being able to track it are very difficult. That's the tough part of investigating this way, and that's why the mainstream science aspects haven't taken it in, because it's very difficult to replicate. It's not demonstrable. So that's one of the things we got to think of. NASA put together this video, and anybody who wants to see it can go to the NECAP site. We didn't have time to show it here. They put together a movie called The Magnetic Movie. This is NASA, National Space Administration. They took, this is an electromagnet here, they took readings with their meters and actually drew out the lines where the energy comes out of these magnetic sources, so you can see them. So if you could see them, this is what the magnetic energy around this field would look like. In the movie, you can see them move, you can see them grow and change, so you get an idea of how it actually works. There's a whole bunch of different things. Like, for example, if you were in this hallway and you had your meter over here, you would be getting a reading. This is electromagnetic fields, these are magnetic fields, and these would cancel each other out. You'd be getting different readings in here, but if you could see it, that's what it would look like, peeking through the floors and walls. And this machine was turned on. These are all done with actual readings, so you could see what it was done. It was done in a scientific laboratory to see what magnetic energy would look like if you could see it. Okay. Now, what I'm going to demonstrate here with this Van de Graaff, I'm going to do a couple different demonstrations, but I want to talk about how this type of energy was in place back then. What you're looking at is St. Elmo's fire. Back in the old shipping days, when they would sail on the open seas, after a storm, the sailors would see this glowing lights around the pointy areas of the ship. These purplish glow, really strange thing, and they would consider it to be St. Elmo, and that it was a sign of their salvation. It was a paranormal experience back then. But what happened is they just survived an electrical storm, and it was creating a corona around the pointy areas of the ship. So it's starting to glow, and everybody would be all excited. They would, they would be fearful of it. But what they didn't realize is if they approached it too much, they would have got zapped because it was full of electrical energy. And I'm sure some people did and thought it was they were being punished for approaching it or some nature of that. In fact, Aurora Borealis was thought to be a god. It was thought to be the god Aurora, and it was, that was where she lived or resided. So people thought that they were looking at the energy from her. Same thing with this. And what we're going to do here today, we're going to create St. Elmo's fire. You're going to get to see what it looks like and see how it can be kind of scary. So if you're ever out somewhere and it's an electrical storm and you see a purplish light glow over anything, it's not a ghost. Don't approach it because you're about to get zapped. And I'm going to show you why. Now we're also going to do some examples. I'm going to show you a little bit of energy induction. First I'll show you this one here. This is a regular fluorescent light bulb. Okay? This has gases in it. Now this is a plasma sphere. Inside here is an electrode. It's the same kind of thing as that Tesla coil over there. It's a very powerful electrode, 20 or 30,000 volts in here. It's stimulating the gases in here, and the different types of gases produce different colors. Okay? What I'm going to show you is how there's an energy field outside of here. You really can't feel it until you get super close, but it's going to affect another energy. It's going to affect the energy inside this light bulb, and just by putting it near it, the light bulb starts to light. And what I'll do is I'll turn down the lights because the next part of this is going to be, you're going to want to see it in the darker area. So you can see, everybody see the light bulb light up near this device here? We're going to show this, I'm going to see if I can get the Van de Graaff to light up the light bulb as well. But just putting it near it shows that energy is affected. It's called energy by induction. And that's the way, if you have a cordless toothbrush or wireless toothbrush, that's how it charges. Same idea. One energy affects another energy, which affects another energy. First law of thermodynamics, energy cannot be created or destroyed, only change in form. That's exactly what you're witnessing here. You never can create energy. Power combustions do not create energy, they transform energy. That's why they have transformers. So let me give you a little bit of a rundown on this. What I'm going to try to do here, I'm going to power this up. This is a grounding plug here. This is going to ground the electricity to from the dome, and you're going to start to see a bunch of flashes. Then I'll pull the ball back a little bit, and you'll start to see a purplish glowing corona. And I'll try to stay down so everybody can see it. See it surrounding it?
Yep.
You can see it? Okay, good. I can know if I can see it down here. Now what we're going to do is we're going to show how energy also can repel. What you're smelling, if anybody smells it, is ozone. You smell that usually after a rain. Because rain produces a lot of negative ions, just like this device here. Basically how this device works is it's gathering electrons out of the air, throwing them up here on this belt. They're collecting in this collector up here, and they're building up a charge. They need to jump to ground, and so they're going to leak to the nearest ground source. Usually I would do this with people, because if you stand on something wooden, you can put this on your head. But what I'm going to show you is how this one energy can move things. So if we put these pie plates up here, what you're going to see, the electrons are going to build inside, and they're going to start to repel each other. And they're going to lift up the pie plates one at a time, and they're going to fly off. Let's give that a shot. Now what you're looking at is, this one is about 1 million volts. It takes 20 or 30,000 volts to jump just an inch. In your house, when you're walking around with socks, bare feet, your socks on the carpet, or you have a sweater on, you're building up a charge of about 20 or 30,000 volts when you get that jolt. In order to get the display like this, we need something a lot bigger. Now, Bill here was nice enough to bring me a Tesla coil, but we even just turned it on once and then the whole house went down because there was so much power. So we're not going to demonstrate it here today because I like you people. Okay? But I think this is the, yeah. So this is what a corona looks like, okay? It's like the aurora. It's a purplish glow. If we had the lights out completely, you'd be able to see that glow a lot stronger. Maybe afterwards, anybody who's staying for the ghost investigation, when we have lights, we can turn lights out completely, and I can show you in the dark, you can see it very, very clearly. It's very bright purple, just like you look at here, and it's very, very strong. It's a very cool effect. This in here is not an aurora, even though it may look similar to it. It's not a corona. This is actually the gases responding to the electrical charge inside. It's similar to, it's not a full corona as what we're speaking about here. It's not release of photons due to that. It's an effect from gas. But the Van de Graaff generator, like I said, produces 1 million volts. That's only 100 millionth of the voltage around a natural bolt of lightning. So this, a real bolt of lightning, is not producible in any laboratory. The science cannot replicate a true bolt of lightning with its full power. This is only 1/100 millionth the power of a real bolt of lightning. And when we have lightning storms, we charge up our atmosphere. People have known paranormal activity to occur before and after electrical storms because it gives an energy to the air. You have to bear in mind that if there is a paranormal energy introduced that can interfere with the other energies in our atmosphere, you're going to get this kind of response. It's going to trigger it. It may push things over the edge where it can move things. I have, and I didn't bring it with me, was a wooden fan. This will actually spin a wooden fan. It will move things that are not in that nature, metal or things of that nature that are attracted to it, like magnets, because it deals with what we deal with called ion wind. And anybody who has an air purifier in their home that deals with ions, you get that breeze out of it. Even I think, what's his name? Dyson invented that bladeless fan. He uses ionic breeze to produce air. And it can move air. When we get our charges in our house, when we're in a place that has a lot of energy like that, it can cause things to move. It may be a short jolt that is enough to move a picture, is enough to move something off of a shelf. These are the things we have to look at when we go and investigate to try to eliminate that cause. And we want to create a trail. And we want to create footsteps and follow to see where the energy happens to come from. You know, so that's I think that's pretty much all I got here. The static discharges that you get, they can reach up to 50,000 volts. If you ever pull the blankets down on your bed, you could get a jolt of 50,000 volts. There's no current in it, though. That's why you're not dying. Okay? That's a good thing. But it's a pretty good jolt that's gonna set your hair on fire. You know, in fact, I wanted to do a demonstration where somebody's hair stands up on end, but we didn't have anything really wooden that's safe enough to stand on, and the ceilings are kind of low, and I'm already jolting this stuff. But I think that's actually all I have right now. Is there any questions about any of this or anything?
Do the pie plates.
Do the pie plates.
Watch the pie plate.
I'll let it run for a little bit and get some good jolts
Watch
out
the
of
pie
it.
plates again.
Let me turn down the lights a little bit so you get the effect of the glow.